Let's be real for a second. Fine-tuning a large language model is incredibly powerful. But if you don't have a solid plan, it can turn into a massive, expensive headache. So, how do we get out of that cycle of just tweaking things and hoping for the best and move into a process that has real, solid engineering discipline? Let's dive into the blueprint for getting it right.
This right here is the whole ball game. I mean, if you're pouring thousands, maybe even millions of dollars into compute time to fine-tune a model, you simply cannot rely on a gut feeling that it's better. That subjective stuff, it's totally unreliable, and honestly, in a professional environment, it's just plain dangerous. You're not just guessing, you're making a very expensive guess.
So what's needed here is a huge mindset shift. You see, in the academic world, the focus is often on things like blue or rouge scores. They basically just check how similar the wording is to some perfect answer. And that's fine for a research paper. But for those of us building real systems that people depend on, we need engineering rigor. That means we're obsessed with correctness and reliability. We use tests and constant monitoring because our goal isn't a publication, it's a rock-solid production deployment.
So, here's our game plan. We're going to walk through a 4-stage life cycle. First, we'll lay the groundwork. Then we'll build out our automated testing. After that, we'll move into pre-launch and live evaluation. And finally, we'll cover how to keep improving everything once it's in production.
First up, laying the groundwork. And I can't stress this enough, this is probably the most critical step of them all. Why? Because if you don't define what success actually looks like before you even start training, you're just setting yourself up for guesswork later. You'll be chasing a feeling instead of hitting a target.
Okay, so the very first thing we do is create our evaluation buckets. And these aren't vague ideas, they're rigid, objective categories. For every single response the model gives, it has to fit into one of these. Is it correct? Yes or no? Is it partially correct? Did it break one of our safety policies? Or, hey, was it just too slow? By doing this, we get rid of all the gray area and make our evaluations super consistent.
And this is how we measure what actually matters to a developer. Forget those fuzzy abstract scores. We're asking questions that have real impact. Did the model actually follow our instructions? We can check that with a simple regex or a schema validation. Is the output factually correct? We can write a rule to check it. Is it just making stuff up? We can check its answer against the database of facts. These are the metrics that tell you if your application is actually working or not.
Now, with that foundation of clear metrics, we can move right into our second stage, automated offline testing. You should really think of this as building unit tests for your AI. This is our first line of defense, the thing that catches problems before they ever see the light of day.
Now, this is a big one, and honestly, it's a total gimme. If your model is supposed to be spitting out JSON, or SQL, or any kind of structured data, this is the most basic, non-negotiable test you can run. Does the output actually match the format you expect? If it doesn't, the model has failed. Period. It doesn't matter how eloquent the text sounds, if it's not usable, it's broken. This brings us to an absolutely critical tool, the golden dataset. Think of this as your North Star. It's a carefully chosen, unchanging set of prompts and the perfect outputs for them. And here's the golden rule, no pun intended. You never, ever use this data for training. Its only job is to be a stable benchmark, a measuring stick, to make sure your new model didn't accidentally break something that used to work perfectly. And the workflow for using it is super straightforward but really powerful. First, you curate it. You want a good mix of the easy stuff, the tricky edge cases, and this is super important, examples of things that have failed in the past. Then you define the perfect answer for each of those. And finally, you build an automated test that runs every new model version against this dataset before you would even consider deploying it. Okay, so our model passed all its offline tests. It's looking good in the lab. But now it's time to step out of that controlled environment and into the messy, unpredictable real world. This is our third stage, pre-launch and live evaluation.
Yep, I'm bringing this quote back because this is the exact moment where that temptation is the strongest. You spent weeks fine-tuning, it passed all your tests, it has to be better, right? Nope, you need cold, hard, comparative data, especially when you're this close to putting it in front of real users.
The classic way to get that data is just a simple side-by-side comparison. Give the same prompt to your old model and your new fine-tuned model. But here's the secret sauce. Have a human reviewer pick the winner blind. They have no idea which output came from which model. This gets rid of all the bias. And listen, if your new model isn't the clear winner by a lot, it's just not ready for prime time.
But what if you could test your new model on all of your production traffic without any risk? Well, that's where shadow mode comes in, and it is brilliant. A real user request comes in, and you send it to your current live model and your new one at the same time. You log both responses, compare all the metrics, but, and this is the key, only the response from your trusted old model ever goes back to the user. It is a full-scale dress rehearsal with zero chance of failure.
And that brings us to our final stage, production and improvement. Getting the model deployed isn't the finish line, not even close. In reality, it's just the beginning. The job of evaluating and improving your model, well, it's never really done.
Now this is how you turn problems into actual progress. Instead of just saying, the model failed, you categorize every single failure. Is it making up facts? Maybe the fix is to use RAG to ground it in real data. Is the format wrong? You probably need better labeled examples in your next training run. This failure taxonomy turns vague complaints into a concrete engineering backlog.
And to get those insights, you need great logging. For every single call in production, you should be logging things like the model version, the fine-tuning adapter, latency, and especially any user feedback, even if it's implicit, like them retrying a prompt. This data is absolute gold. It tells you exactly where your model is weak and when it's time to go back and retrain.
And because we all know that things will go wrong eventually, you need an escape hatch. A rollback should not be a 5-alarm fire. If you separate your fine-tuning adapters from your main model deployment, rolling back to a stable version can be as simple as changing one line in a config file. It's instant, it's safe, and it lets you sleep in.
Okay, so let's boil all this down. First, stop thinking of evaluation as some fuzzy academic thing. It is your testing and monitoring. Second, always define success before you start training. Third, use those golden data sets to make sure you don't go backwards. Fourth, use shadow mode to find problems before your users do. And finally, the golden rule. If you can't automatically validate it, you can't ship it.
And really, if you take one thing away from this whole explainer, let it be this. The second a model starts serving production traffic, it is no longer a cool science experiment. It is a critical piece of your software, and it demands the same level of rigor, testing, and monitoring as anything else in your stack.
So I'll leave you with this one question to think about. When you really look at your own process for fine-tuning models, is it just an expensive guess, or is it engineering? Thanks for watching.